Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problem section. And if you scroll down in the search bar, search the majority element and hit enter. You could see like one question majority element, one question number 169, and it's come under the easy category. So let's open it. So the question says, given an array nums of size n, return the majority element. And what do you mean by majority element? Majority element is the element that appears more than n by 2 times. So this is the condition. Don't confuse with the term majority element, like which comes like more times. All right. So generally that can't be the majority element, but they have specifically mentioned majority element is that element which appears more than like n by 2 times. So let's suppose if there is an array, let's suppose if Mm, sorry, 1 minute. So let's suppose if there is an array with 1, 1, 2, 3, 4, 5, and 6. So one appear 2 times, 2 appears 1, 3 appears 1, 4 appear 1, 5 appear 1, 6 appear once. So we can't say that 1 is the majority element, because the definition of the majority element is the element which appears by n by 2 times, and n is the length of the array. So length of the array is like 6 and 7. So 7 by 2 is equal to 3.5. But 1 appears only 2, which is less than n by 2. So 1 is not a majority element. All right. So majority element is that element which appears more than n by 2 times. All right. So you may assume that the majority elements always exist in the array. So it means they said there like there the examiner will not provide you such array which doesn't have any majority element. The element whatever will be provided that definitely have the majority element. It means so there should be one element which appears more than half of the times. Like in example 3, it appears more than 1.5 times. And in this, like 2 appears more than half of the times. Right. So that is a majority element. So, okay. So let's try to like do the question. So 1 minute. Okay, so input numbers 3, 2, 3. So 3 appears 2 times, 2 appears 1 times, and n is equal to the size of array 3. So n by 2 is equal to 1.5. So 3 appear 2 times, which is greater than 1.5. So answer is 3, because 3 is the majority element. So similarly, second example, 2 appears 4 times, 1 appears 3 times, n is the size of array, which is 7. So 7 by 2 is equal to 3.5. So is 3 greater than 3.5? No. So 1 is not a majority element. 4 is greater than 3.5? Yes. So 4 is the majority element. So for the element, sorry, element 2 is the majority element, and 2 is the answer. Right. So let's try to do this solution with using extra space by using the hash map. So by using the hash map, what we can do is we can create a dictionary. We can scan the element, and we can store the element as a key and value as a the number of times that particular element will come. So let's try to do that. So we will take a hash map, right, and we will try for number in nums, right. For number in nums, then we will store the number in the hash map by what value. So the current value of the hash map dot get current value of the key plus 1. So an example, so if we consider this array 2 2 1 1 1 2 2, so we start with the 2. So is 2 in the hash map? No. Like even we don't need to check the loop. So if you want to do check the loop, so you can also check the loop, but this is like a shortcut way. So uh, that's why we are using the get method. If you don't want to use the get method, then you have to use if else condition. So first check with 2. So for 2, we need to assign into the hash map. So in the hash map, how you are going to assign key as a 2, value as a 1, right? So key, so first we will get the existing value, because 2 might exist within the current hash map. So we are getting the we are getting the existing value of the particular number. If the number doesn't exist, then by default 0, and we will add 1. Then the next two. So next two will come here. Uh, then we will get the existing value of 2. Existing value of 2 is 1. Then 1 plus 1, 2. So now the value of number is 2. Right? So we will get one dictionary. Now we will normally do like for key comma value in hash map dot items, and we will check if value is greater than. So what is n? N is equal to length of nums. If value is greater than n by 2, because it is mentioned majority element is the element that appears more than n by 2 times. If value is greater than n by 2, then we have to return key. Key means the particular number, because we are creating a dictionary with number as a key and value as their number of occurrence. So we are going to return key. So let's run it. So question has been accepted. So let's try to submit it. So it has been accepted, right? So let's go back. We can do using like one more approach, and the approach is using the collections module from collections import counter. It is more or less same only, like there is no such difference. So basically, like what we did earlier is we manually created some dictionary by running one loop from start to end by counting its element, right? So counter is an inbuilt module within the collection package. It will convert the list into the dictionary. That's it. So we don't need to run the first loop. Earlier we run two loops. Like that is the individual loop, that is not a nested loop, but we run two loops. The one loop to create a dictionary, the second loop on the dictionary. So we can directly use the counter method on the nums. So it is going to return the dictionary only. So dictionary is like 2 comes 4 times, 1 comes 3 times. Then we can normally do key comma value in hash map dot items. Right. If value is greater than, so let's suppose n is equal to length of nums n by 2, then return key. So we can do that as well. So let's try to submit this. So that is perfectly fine. So we are doing that. But if you scroll down a little bit more, there is a follow-up. In the follow-up, it is mentioned, could you solve the problem in linear time? Yes, we are solving the problem, even the earlier approach as well, even using the counter, because more or less it's same only. Using the linear time only, but we are using the extra space. Earlier, we also use the hash map, so we are using extra space. In this question, in this method as well, we are using the extra space hash map. So how we are going to do in a single space? Like we don't need to use the extra space. We can use just variable ABC, but you can't use the like a whole list dictionary kind of a space. So, but only one loop. So how we are going to do that? Because if we have to run that, we have to like store the sequence, like how many times 2 comes, how many times 1 comes, how many times 3 comes. All right. And the array itself is not sorted. All right. So if even if we do the sort, then like the time complexity will going to increase, because it's not then n, not big of n, it will be become big of n log n. Right? So it is going to increase, but we need the linear time complexity. So linear time complexity means it is sure we need to run only one for loop. That's it. And we don't need to use the extra space. So only one for loop we need to use. So what is the other approach? So if we do the follow up now, then I will not consider this is an easy category. Right? But till this, if we don't do the follow up, then it's come under the easy category. But examiner said, okay, you did this using the some extra space, that is perfectly fine. Solution is working fine, and it has been accepted by the Leetcode. But can you avoid the extra space? Is there any method? So yes, there is an algorithm, and the algorithm is the Boyer-More majority vote algorithm. All right. So in this algorithm, so this is the algorithm. This is the very small algorithm. So if you know the logic now, then algorithm is very, 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 very simple. But when the examiner generally said, to be honest, it's very rare, like case it will like come in our mind. If we know this algorithm and recently we did that, or maybe by using this algorithm we solve thousands of questions or hundred of questions, then it can come in our mind. But suddenly, like it will be very difficult that algorithm will strike in your mind, right? So Boyer-Moyer like majority vote algorithm. So what this algorithm said, so it is sure that we need to run only one loop. So the key element of this algorithm is, because it is mentioned the majority element is the element that appears more than half of the time. Right? So it is sure if there are 8 elements, then the majority element has come 5 times. That is more than half. So 8 by 2, 4. So more than half. It means 5 times or minimum 5 times. So more than half. That is the only key element of the particular algorithm. All right. So and in that algorithm, what we have to do is, so let's try to do the solution with some extra space. And the algorithm name is like Boyer-Moore majority vote algorithm. And the key fact is that we know that majority element which is greater than n by 2, which is not greater than, which comes like a like count, or you can say count is greater than n by 2, which means majority element comes more than half times, right? So if numbers are this, so n is equal to 13, total number of element is 13, n by 2 is equal to 6.5, majority element is 1. So because 1 comes 8 times, which is more than 6.5, right? And we don't know to use the extra space. And so, and we need to run this in a linear time. So it is sure and final. Whatever the solution we will write doesn't matter. That should only contains one loop, one for loop, and that should not use the extra space. That is fine. So we have to use only like for loop for n into nums. That is also fine. So what we have to do is we will take it two variables. Count is equal to 0, result is equal to 0. Here we are taking two variables. We are using space, but these are the constant space. So it is not included in your space complexity. So we will take two variable, count and result. So this is the algorithm only, very small algorithm, and I am explaining in the Word document here. Right. So what we will do is we will scan all the element. All right. So there are only two if condition. That's it. We will scan all the element. So we will start with one. All right. So we will check if count is equal to 0. So count is in starting 0. Then we are going to assign our current element into the result. All right. So that is the first condition. So if count is equal to 0, then we will assign our current element, whatever the current element, into the result. All right. Okay. Then we will go to the next if condition. There is no else condition. Then we will go to the next if condition. So if current element is equal to the result, yes, current element is 1 and result is also 1, because in the first if condition we already assigned result is equal to 1. Then what we will do, we will going to increase the counter by 1. If current element not equal to the result, then we are going to decrease the counter. And at the end, we are just going to return the result. That's it. Because because we know the majority element comes more than that, more than half of the times. So definitely we will get that answer at the end, which comes more than half of the time. So as an example, so far number are this, like count is equal to 0, result is 0. So we will start with number 1. We will start with number 1. So what algorithm says if count is equal to 0, right, then we are going to assign the current element to the result. So if count is 0, then we are going to assign 1 into the result, right? Okay, then we will check the next if condition. So if result equal to the current number, so now result is equal to 1, result is equal to the current number, yes, current number, then we are going to increase the counter. Then we are going to increase the counter by 1. So after the first loop, our answer is count is equal to 1, result is equal to 1. Okay, then we will pick the next element, 3, right? So then we will check the first loop. If count is 0, no, then if loop skipped. Okay, the next if condition. If a result is equal to number, no, result is not equal to the number. right? Then we are going to decrease the count. So now count is equal to 0, count is equal to 0, and result is still 1 because we are not assigning, we are just decreasing the count. Then we will go to the third element, 4. So is count is equal to 0? Yes, count is equal to 0. So first condition satisfied, right? Count is equal to 0, then we will assign that particular variable to result. So result is equal to 4. Then we go to the next if condition. In the next if condition, if the result is equal to the count, so using the first if condition, we are going to count is equal to 0, result equal to 4. And the second if condition, if result equal to the current element, yes, result equal to current element, then we are going to increase the count. All right. So at the end, so we are getting count is equal to 1, result is equal to 4. So similarly, the next one come. So next one come, so which is different than the 4. So count is not equal to 0. We are going to skip first if loop. In the second loop, so the next element is not equal to the result element. So we are going to reduce the count. All right. So we will do like this only, and at the end, but what will be happen? So count is equal to 3, result is equal to 1, and 1 is the only answer because 1 comes more than time because we are increasing the count. All right. And we know even if, so as an example, so let's suppose you have 1 1 1 1 1 and 2 2. All right. So in the initial count is equal, because using only two elements, maybe it's very easy to understand, and result is equal to 0. Okay, we will start with 1. So we will assign our result equal to 1 because we can't store anything, right? So result is equal to 1, and we are going to increase our count as well. Count is equal to 1. Then count is equal to 2. Then count is equal to 3. Then count is equal to 4. Then count is equal to 5. All right. Then we get the some different element which is different than the result. Then we are going to decrease the count 4. Then there is a different element. Then we are going to decrease the count 3. Let's suppose if there is one more element, right? Then we are again going to count the 2. Let's suppose if there are some more element, different element, then again we are going to count the decrease. But it's definitely sure we will not get some different element, because if we get the different element, count will become 0, and then 1 is not the majority element because 1 come exact 5 times, it doesn't come more than 5 times. All right. So that is the only key element, because we know the majority element will comes half of the time. So if half of the time, then definitely the count will be there. There should be something within the count. So let's try to implement that. So what we have to do is, so let's remove this. So let's remove this as well. So, so we have to get two elements. Count is equal to 0. So count and result is equal to 0 comma 0, right? So for number in nums, all right, so we will scan all the numbers. So if count is equal to 0, we know if count is equal to 0, then we are going to assign the current element to the number. All right, so this is the first if condition. The second if condition is if result equal to the number, then we are going to increase our count element. All right. If current number is not equal to the result, then we are going to decrease the count element. And at the end, we are going to return the result, because result contains the number and we need the number as well. So let's try to run it. So it's accepted. So let's try to submit it. So it has been accepted. All right. So that is the follow-up. It's like the solution is not, I can't say like it's very complicated. We are doing trees, quiz. Like its solution is very easy. Just the thing is, if this algorithm we know, like what this algorithm, and this algorithm comes in our mind during the coding test, then it will be easy. Otherwise it's very difficult to like get this like to understand, because the first approach will come in our mind is the hash map, and most of the people solve using the hash map, and that is totally fine, because if you see the easy category, then hash map is totally fine. But we want to do the follow up as well. That is a follow up. If you want to do that, that's okay. If you don't want to do that, that is still okay. But we will do if we know it, right? So that's it. That's the end of this video. Thank you. You can also try.